All right. All right, so where are we? Okay, introduction to your normal distribution. This is the bell curve. Okay, we've all seen the bell curve before. So we have the mean, median, mode. What are they? They're equal. Okay. The normal curve is bell-shaped and is what? Symmetric about the mean. The total area under the normal curve is equal to 1. The normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. Okay, that's number 4. So you're going to see some of the drawings and graphs that I have look like it touches the x-axis, but it doesn't. At 1 standard deviation away from the mean, the graph curves downward. These 2 points are called inflection points. Okay, and I'll go over what that means as well. The normal distribution can have any mean and any positive standard deviation. These 2 parameters, the mean and the standard deviation. So I think they give you those 2, correct? All right, now that's the mu. Okay, lowercase sigma, that's the mean and standard deviation of a what? What do they stand for? That's the mean and standard deviation of a population. Okay? Now, they can also give you the mean and standard deviation of a sample. So you can also have your x bar and your s. Okay? So don't be confused and say, oh, they didn't give me a mu, they gave me an x bar. All right? They're going to be the same. And they determine the shape of the normal curve. Now I have an A and a B up here. What I want to do is I want to change the color. So we're going to call this one A, and we'll call this one B. Okay, so those are your 2 curves, the 2 normal curves. So they have a mean, they have a standard deviation, and then they're distributed. Okay, so the mean of A would approximately be right here. Okay, so that would be the mean of A. It's at the highest point. So A looks to have the highest point right there. B has its highest point right here. Therefore, the mu of B would be located around there on your x-axis. Okay? Now, which curve has a greater mean, A or B? B. Okay? So B has a greater mean. Now, which normal curve has a greater standard deviation? A has the greater standard deviation, because what happens is it'll spread out more, okay, with the standard deviation. Now, a couple things with the curves. Like I said here, okay, my graphs touch the x-axis, okay, but what will happen is the curves will actually go out and not touch the x-axis. And the same thing here, okay. Most of your data will fall in the scope of this curve. But because of outliers, you can have something far to the left or far to the right. Okay? Now, inflection points, what does that mean? So it is difficult to see on these curves. The ones in the book are a lot easier to see. So we're just going to say maybe here and approximately there and there. So these are your inflection points. Okay? Now, an inflection point, when you look at your notes, at 1 standard deviation away from the mean. So the inflection point occurs at 1 standard deviation away from the mean. Okay? What an inflection point does, it changes the concavity of a curve. So that means that if we look at this curve here, from this first inflection point to the second one, we call this opening down. Okay? Now, because of this inflection point, it then opens up. Okay? And that's what an inflection point is. You learn more about it as you get into higher level math. Okay? But that's what happens at 1 standard deviation. All right? That's about all as I'm going to talk about inflection points. Okay? As long as you understand the standard deviation, the area under the curve, what percent is represented by values, that's what this chapter is about. Okay? But when you see them talking about inflection points, that's in a nutshell what it means. Okay? Any questions on those? Okay? The mean and median of the normal distribution are always at the center. Changing the mean but not the standard deviation simply moves a curve along the horizontal axis but does not change the spread. Okay, so all you're doing is shifting it left and right if you change the mean but not the standard deviation. Okay, interpreting graphs of normal distribution. This is what they showed you on page 242, where they were interpreting the graphs. They were talking about the height of fully grown white oak trees normally distributed. Okay, they gave you values. I think they said that this was 90. Okay, and then they had values up by 5s and a little more. So 95, how high did they go? Okay, about 100. So they spread it out a little more, which is okay. So I'm going to interpret this a little different just so it's ease for you to see what is going on. So I am going to say that this curve has a mean of 90 and a standard deviation of 5. So the mean is always in the middle. The standard deviation of 5 means it goes up 5 for every standard deviation and down 5. So if I follow the 85 up here, okay, and the 95 up here, what are those 2 points called? Inflection points. Okay? Now it's not perfect with my graph and drawing, okay, but you'll be able to see it a lot easier in the book. So if you do look at page 242, and because their spread was a little different, they have their standard deviation 3.5. Okay, I had mine just easy, something easy. You can just add the 5, add the 5. Okay, so if you look between the 2 inflection points, from this first one to the second one, you can clearly see that it opens down. Okay, and then as you look at the curve on 242, okay, I'm looking at the second one of the curve in the middle, you can see that it does shift. Okay, more so like this curve up here. So this one opens up, this one opens down. Okay, and that's what happens. Okay, and when you draw your curve, it doesn't have to be perfect. Okay, when you look at the ones in the guided notes, you can say it doesn't match. Okay, but that's okay. Okay. All right, z-scores. Standard normal distribution, z-scores. So what happens is we deal with x values. Okay, that's what we did in the last chapter. We dealt with actual values. So whether we're talking about salary, ages, temperature, whatever, we can change everything to a z-score. And then the z-score can be related to a p-value, which is a percentage. Okay, so that's what they're talking about with the percentage under the curve. Now, your z-score has this formula right here. Okay, z is the value that you're looking for minus the mean all over the standard deviation. So SD is standard deviation. Now, the 2 formulas that we have are here to the right. So we have x minus mu all over the lowercase sigma. All right, and that's if you're dealing with a population. Or you can have the z value equals x minus x bar all over, and I'm going to change this. I don't know if I can use green or not. Oh, no, come back. Okay, for some reason. And I'm going to make that an S. All right, and remember, this is your sample. Okay. Sometimes the only standard deviation you know is the population standard deviation. Sometimes the only mean you know is the population mean. Okay? So these 2 formulas can be interchanged because they're the exact same formula. Okay? Standard normal distribution. This is what we call a z-curve. Okay? So we go from an x-curve. An x-curve is using the real data. So we go from an x-curve to finding a z-curve. And some properties here. of your standard normal distribution. All right, the cumulative area is close to 0 for z-scores close to z equals negative 3.49. Okay, it's close to 0. The cumulative area increases as the z-scores increase. The cumulative area for z equals 0 is 0.5000. Okay? And the cumulative area is close to 1 for z-scores close to z equals 3.49. Now, you can have z-scores that are greater than 3.49, and you can have z-scores that are less than negative 3.49. Okay, those are outliers. Okay, they're not very likely to happen, but they can. Okay, now the table we're going to look at is in the back of the book, and there's a couple different places for this table. So we already used table 2, which was the binomial distribution. We are going to go to page A16 and A17. This is your standard normal distribution. It's also in the pullout. Some of your books have the pullout. Okay, like this. Okay, if you have one of these. Okay, don't rip it out. If it's still in there, you can use it. Whatever's convenient. It's the same thing. It's table 4. Okay, so a couple things that we will talk about. One of them is cumulative area. Okay, so cumulative area means that it is all the area from the furthest point left up to a point on your x-axis. Okay, so, oh, there it is. Find the area on the curve. So here it is right here, cumulative area. Okay, so when we talk about cumulative area, that's what we're talking about. So, and you can just hang back there at that page A16. So cumulative area that corresponds to a z-score of 1.15. So in a z-curve, so this is a z-curve, the mean is always 0. Okay, because that's what happens. We take our mean, whatever it may be, and like I said, you could use anything. It could be salary, temperature, grades, weight, anything at all. And that mean will always equate to 0. So your location of 1.15, here's 1, 2, 3 standard deviations. 1.15 is approximately there. Okay? Everyone okay with that approximation? So cumulative area is all this portion of the curve. Okay, so it's from the furthest point left up to your corresponding z-score. Okay? Now, if we want to find the cumulative area that corresponds to that z-score, we have to go to our table. So when you go to your table, you can see table 4 on the left side, the z values on the left column are all negative. See how they're all negative? Okay? So if I go to page A17, or the one on the right side, depending on what you're using, you can see all the z-scores are positive. So this is a positive z-score. So we follow the z down the column till we have 1.1. Bree, are you with us? Where are you? No. Okay? And then you follow across the top. You see across the top where it's 0.00, 0.01, 0.02, 0.03. So that means I need a 0.05. So I go over to 0.05, come down with the 0.05, come over with the 1.1. And this is why I said 0.5000 was the cumulative area at 0, because they give you 4 decimal places. Okay? Everyone should have a finger on the value 0.8749. Does everyone find that value? Okay? So that is the cumulative area that corresponds to a z-score of 1.15. So it's 0.8749. Okay? Now, what does that mean? So this here, I set a z, I set an x, I also set a p. This is actually a p-value. Okay? So it's a percent of the data. So This means that 87.49% of the data is less than 1.15 standard deviations above the mean. Remember how we talked about our empirical rule? 68% of the data is within 1 standard deviation. 95% of the data is within 2 standard deviations. Okay? So now we want to find other values, not just 1, 2, and 3. Okay? But we want to find any value that they give us. Okay? Does that make sense? All right. Now, the smallest value that we said was negative 3.49 and 3.49. So if you look at A16 on the left side, the corresponding cumulative area of negative 3.49, okay, is everyone with me there? And the negative 3.49 is 0.0002. Okay, does everyone see that? All right, so that's where it said at negative 3.49, it's close to 0. Okay, so it's 0.0002. So anything less than negative 3.49, we are going to use 0.0001. And that will hold true for the rest of the course. So if you have a z-score that is less than negative 3.49, you will use a p-value of 0.0001, always. It doesn't matter if it's negative 3.5 or if it's negative 22.7. Doesn't matter. You're going to use 0.0001. Okay? If you look at 3.49 on the next page, it has a cumulative area of 0.9998, which in our notes says it's close to 1, which is true. So if we have any values that are greater than 3.49, we are going to use a cumulative area of 0.9999. Okay? Any questions on that? Okay. We will practice with it. We will use it. All right. So this table we're going to use throughout this chapter. Okay. So make sure that it is accessible. All right. Example 3, the cumulative area that corresponds to a z-score of negative 0.24. And it is always helpful to draw a curve. And again, this is a z-curve. 0 is always in the middle. 1, 2, 3 standard deviations below and 3 standard deviations above. Negative 0.24 is approximately here. And so I'm talking about cumulative area. So it's area to the left. So we should all still be on A16, table 4. So I am looking at a z-score of negative 0.24. So I go down the column to negative 0.2. Now you have to be very careful. If you look at the top, it goes 0.09, 0.08, 0.07. It goes down on the left side. Look at the table on the right. You see how the numbers at the top go 0.00, 0.01, 0.02, so they go up. So you got to be very careful of that. Okay? So negative 0.24 brings me to a corresponding cumulative area of 0.4052. Okay? Is everyone all right? Yes? Good? Okay. So that makes sense, should make sense, because if I'm here in the middle, okay, if I'm at the mean, which is right here, the cumulative area for z, oh, didn't come up, okay, is equals 0, is 0.5, and there should be another 0 on it, 0.5000, okay, because that's 50% of the data. It's right in the middle. So 50% of the data should be below, 50% should be above. Just like that's why, oh, this has got to be greater than 50%. This is less than 50%. Okay. Finding area under the standard curve. Guidelines. So this is kind of what we already did. Okay. Sketch the area under the normal curve and shade the appropriate area under the curve. All right. Some of you get this quicker than others. It's fine. No big deal. Okay. Some of you will have to sketch this every single time. That's okay. Okay. It's not a problem. When you sketch it, you will usually arrive at the correct answer. Okay. To find the area, this is what can happen. We have 3 scenarios. So find the area to the left of z. Find the area that corresponds to z in the standard normal table. That's what we just did. Those were the 2 examples I just did with you. Now, to find the area to the right of z, we have to find the area that corresponds to the z value. We have to find the cumulative area. Then subtract that area from 1. Because the total area under the curve is 1. Okay? Now, to find the area between 2 z-scores, find the area corresponding to each z-score in the standard table, then subtract the smaller area from the larger area. Okay? So those are the 3 scenarios that can happen. So find the proportion of observations from the standard normal distribution that are less than 2.22. All you have to do is identify where 0 is, 2.22. Less than 2.22 is right here. Proportion, that's okay. They're talking about proportion. They can talk about percentages. They can call it cumulative area. All right, they'll use a lot of different terms. So less than 2.22, that's just standard cumulative area. So 2.22 gives me a cumulative area of point what? 9868. Okay, so we're at 0.9868. Would that be an unusual value? Yes, it would be. Why? Okay, above 95%, be careful, okay, because 95% of the data falls within 2 standard deviations. Okay, so good idea. But what happens is it'll come in this way too, so this might be cut off. So at, let me see what we have here. You see what I have at 1.90? You see 1.90 is 0.9713? Okay, so that's greater than 95%, but that's not unusual. Okay, good idea though. Okay, now the rationale when you're looking at this right here is because this is more than 2 standard deviations above the mean. Okay, remember your min and max usual values are 2 standard deviations above and below, and that's where 95% of the data comes from, so that's where she got that from. Okay, so that makes perfect sense. Okay, but min and max usual values are 2 standard deviations above and below. Okay, now I put this one on here, negative 0.197, because if you look at your table, table 4 on the left and the right, how many decimal places does it go? It goes 2 decimal places. Okay, I will never tell you where to round a z-score because it only goes 2 decimal places. That's where you round it to. It'll never say in the directions. Okay, but you always have to round it to 2 decimal places. So I have to change this to negative point. How does that round to 2 decimal places? 0.20. Okay, so then we draw another curve. 0, 1, 2. Negative 0.20 is approximately here. Okay, but now be very careful. Okay, some of you had problems with this on the test. If you're greater than, no more than, less than, okay, this is greater than. So that means I'm looking for this portion of the curve. So this is the second scenario up here. To find the area to the right, then subtract from the area. Okay, or subtract the area from 1. So we have to find the cumulative area, which is this portion right there. Cumulative area, the area to the left. So I look up, and if you need to put the 0 in, by all means put the 0 in. So it's negative 0.20. Be very careful because it's not the first one. It's all the way at the end. So it should be 0.4207. So that's this portion right here, 0.4207. That is unshaded. Okay, that is unshaded portion. So to find this shaded region, I have to do 1 minus 0.4207. Which gives you 0.5793. Okay? Does that make sense? So that's the second scenario. Tomorrow we're going to work on a lot of these. Just practice. Like I said, some of you will get it quick. Some will need a little more work, which is perfectly fine. Okay? And this is the last scenario. Here's my 0. 1, 2, 1, 2. Okay, so I have negative 0.15 and 1.32. So I'm talking about this shaded portion. So the area between those two z-scores. So you have to find two cumulative areas. You have to find the cumulative area up to 0.15, negative 0.15, and the cumulative area up to 1.32. You have to find those two values. So the cumulative area up to the negative 0.15 is 0.4404. Come on. So you got 0.44. Back. All right. 0.4404. And the other one at 1.32 would be 0.9066. All right, it's back. 0.9066, and the other one's 0.4404. Okay, those are the two cumulative areas. So this is the third scenario. So in order to find this shaded portion, I have to do 0.9066 minus 0.4404, and that gives me 0.4662. Okay. So we'll work on that tomorrow. Okay, and we'll address questions as you try to do these problems. You run into some complications, okay, but the more you practice, the better you will get.